here, so I do one of my other classes.
You didn't record yesterday.
No, I did it in the other class. Yeah. Sometimes with announcements and everything that comes on and off first period, it's a little tougher. All right, so go through these and see if you have any questions. We're looking at, is it a function? Yes, it passes a vertical line test. And therefore, once you do this, you can kind of see your connection. You can use every single x value. All your x values are being used. Now, your y values are good up here. They're all up here, but there's none down here. Extend your lines. Sometimes that's an easier way to look at it. Just extend the lines. So down here, there's no y values. This is your cutoff right here at this open circle. So from -4 all the way up to infinity. The next guy, similar. There's your vertical line test. You can use every x, but only from 0 on up, and you can't use 0. If you have any questions, stop me. These are important that you catch these domains and these ranges. Okay. It's Friday, thank goodness. Who just yawned? Okay. Domain, again, all real numbers. Now this time the range went the other way. If you extend these, it's coming all the way down. All of these down here I can use, but none of these. Play with your graphs a little bit. It's an easy way just to mark them off. So be careful on your range. You come from -infinity and you stop at 3. You have to read your number line from left to right. So just be careful the order you put it in. Very similar, but this time we can use 3. Good? Okay.
Seems like all of the domains are the same.
Yeah, pretty much. Pretty much. It's the range you pretty much have to catch. Questions? Just a good exercise in getting used to your domains and your ranges. Go back up? Sure. These again are piecewise functions. These are piecewise. And when we get a little further into the course, we'll be doing these ourselves. We'll be setting up little tables for each part of the graph and having a different equation for it. And where one begins, the other one's ending at the x value, which leaves us no gaps, which is why domain is all real numbers. It doesn't always work like that. You can have gaps in them.
You explain number 7.
Sure. You okay with the domain?
Yeah.
Okay. Now your range, this guy is coming all the way down here. This guy is coming all the way up there. So there's no place that you can't use. See it? Extend your lines. Extend them. So if I say here, oh, it's covered with this one. If I say here, oh, it's covered with this one. It used every single, right? It just overlapped right here. But look at this as almost one continuous line. See it? Extend your lines. I think it's so much easier to see. These are nice because it kind of just gives you the bottom number here. Questions? Good. And I think that was it. Any questions on these? Find your domain restrictions like we did yesterday, algebraically first. So, let's take a look at the first one. There's 3 domain restrictions. One with a fraction in the denominator, one under a radical, and 1 with the radical in the denominator of a fraction. Does this function have any domain restrictions? No. Which means, what will our domain be? All real numbers. Our domain is going to be all real numbers. We're not going to have any domain restrictions. Now, before you put this in your calculator, let's see if we could just take a look at this. Tell me what kind of graph you think this is going to be. Algebra. A parabola. Good. Which way is it going to open? Up or down? Down. It's opening down because of this negative. I'm going to rewrite this like this. Now, I want you to think. I want you to constantly think transformations in here. Because we always start with a parent graph, a core graph. It's going to start like this. Down. And what is this plus 4 going to do? It's going to move it up. Everybody's going up 4 blocks like this. And it's going to look like this. So I want you to think, before you put them in your calculator, I want you to visualize. Break these things apart. You're going to learn so much about graphs, you're never going to use your calculator to graph anymore. So now, let's put this in your y equals. Let's do a Zoom 6 standard graph, just in case there's something different in there. Other classes use my calculators too, so I never know, if they're doing anything in them. So let's put that out there, and let's have you graph. Get me the graph. Yes. Okay, get it on your paper. Get it on your paper. So, Rich says it's got a vertex here of 0, 4. It goes up to the 4. Turns. We know it's turning down, right? Easy way, because this is a standard 1. It goes 1, 1. Then it goes 2, 4. If you start getting used to just a couple of the patterns, it makes things a lot easier. And don't forget, when we sketch in this course, we're going to be sketching. We're not going to be counting numbers. We're just going to go like this. We're going to say it's a parabola and it opens like this. Right now I want you to get domain restrictions and ranges, so I kind of want you to see them on the grid. So your parabola is opening down. Is this a function? Yes, this is a function. What's its range? Good. Can we use 4? Good. Everybody's good with that one? Okay. All right. Let's jump down. We're going to jump down to a different one. To number 3. Does this have any restrictions? Number 2. What was the second restriction? Radicals. What can we not have under a radical? Negatives. So, we said, take what is underneath the radical and set it to what? Not to 0. Greater than, good. Greater than or equal to 0. Good. So our domain is going to be x is greater than or equal to 3. I put negative 3. If I put a negative 3, I get a 0. I can take the square root of 0. If I put a negative 2, I get 1. If I put negative 1, I get 2. If I put a 0, I get 3. So I'm good to go. So from negative 3 to infinity. Now, let's just think, that's your domain. Let's think about your range for a second. Now, this normally without the plus or minus in front of here, we'll just say anything can only come out positive, right? This plus or minus says I'll take either root. I have to actually put 2 equations in here. I have to actually put the plus 1 in here, and I actually have to put the negative 1 in here. But, no, not on your y equals. You can only do one at a time. because your calculator is in function mode, it only can do a function. It can't do the two pieces at a time. But we don't know this guy. That negative is a reflection. A reflection over where? The y-axis or the x-axis? So think of it like this. If the negative is next to the x, then the x is going to go from positive to negative. It's going to be over the y. But the negative is close to the y. Because whatever it is, you're going to make your y negative. So the y's go like this, from positive to negative. So where's your reflection going to be? Over the x-axis. Okay. I don't expect you to know this, but I want you to start thinking like this. Now, yesterday, you remembered that when it's next to the x, this is a horizontal shift, and it always goes the opposite way, right? Which is why we started at the negative 3. So normally, your radicals go like this. It doesn't have any negatives. And if we shift it, it's going to go like this. And if we reflect it, where's it going to go? Underneath it, like this. Here's your parabola. See? This is one of your x squareds. Your x squareds, because we can't do x squared in your calculator. X squared, we can't do a y squared equals. This is like your y squared and your x squared. We can't do a y squared, so we have to take the square roots. Okay, so let's get this down. We know our domain. It's not going to be a function. If it was without the plus or minus, it would be. So get your first one down. Get the one down with the plus in it, and let's take a look at that. Put it in your calculator with just the plus. No, you don't have to put a plus in there. It's understood. No negative yet. Just do this one. See the domain restriction? Look in your calculator at your table. What does it say for negative 4? Error. It says error. That kind of helps us out. That means we had some kind of a domain restriction. If any x says error, we have a domain restriction. We found it algebraically. We know what it is. So then we put it in our graph and we figured it out. Now, one way to do this is go to y2. And in y2, put in the negative. Make sure this is a negative sign, not a subtract. And then you're going to see 2 steps. Your calculator is going to do one arm of it and then second arm of it. It's just a complete reflection right here. Here's your reflection. So what's the range to this thing? Well, not just on the graph. Don't forget this goes on and on. Even though it's narrow, it still goes on and on. Just like your parabola that does this. What's your range for this guy? Well, what's your domain for this guy? Negative infinity to infinity. And is this a function? No. By itself, with the positive, yes. With the negative, no. I want you to start seeing a lot more into these graphs. Domains, ranges, x values, y values, where it's turning, where it's opening. Okay, let's jump down. Okay, I don't want to do that one. Let's do, do we have time to do 5? Yeah, let's do 5 together, the sine curve. Let's do your sine curve together. Does everybody remember what the sine curve looks like? Mm-hmm. Like this. Good. Is it a function?
Yeah.
Yes. Okay. So we have a couple of ways we can do this. Let's just do our basic quadrant. Let's go off our unit circle. Okay, let's go off your unit circle for your sine without your calculator. So on your unit circle, it's 1 unit up, 1 unit over, all the way around. Okay. Does anybody remember on the unit circle which value is the sine, the x or the y? Y. Sine is the y, the cosine is the x. And an easy way to remember, x before y, c before s. So, this is the 0 degrees, and it has a sine of, find the y value, 0. This is the 90 degrees, it has a sine of 1. This is the 180 degrees, it has a sine of 0. 270 has a sine of, and 360 has a sine of 0. So if we follow this pattern, 0, 1, 0, negative 1, 0, there's our sine curve. So let's make, can we go by 2s? 2, 2, yep. Every 2, make this a 90 degrees. And go up 2 and make it a 1. This way we have a little bit more space in there. That's a negative 1. Now, plot your sine curve. At the 0, you're 0. At the 90, you're 1. At the 180, you're 0. 270, negative 1, 0. Here's your sine curve. And reverse it to come out the other way. Negative 1, 0, 1, 0. See it? Unit circle. Unit circle says everybody's one unit on a unit circle. Your radius is 1. In my calculator, if I put y equals sine of x, then what do I have to do? Put your mode in degrees. Let's give this a try. Put your mode in degrees. I think I have a calculator. This is going to take me a while to get my calculator out. Put your mode in degrees. Put y equals sine x in your y. Yeah, do zoom 7. You got to put it into a trig graph. Now it does something, right? See it? Now when you go back to a regular graph, you have to put it back into zoom 6. But you need to be in trig mode to be able to get there. Y equals sine of x. Put your calculator in degrees. If we were going to set your table, we could set your table every 90 so that you could see it. Go to table set. Mode. You could leave it in it'll work at radians, but then you won't see it in your table as well. Go to table set. Second window, table set. Start at 0 and increment by 90 degrees. And now look at your table. Oh, good. Do your table set. Start at 0, go by 90s. Make sure your mode is in degrees.
I'll lay a street light before she runs around because I don't want to stab.
Okay, you should be able to get that. Good. Now when you look at your table, you should see the same thing that we just traced through.
They never do it.
Okay. For homework, finish this for homework. Grapha, I don't think there's any more, except the last one you have to do make restrictions. Do it on this house. The last one's a little different.